All right, let's take a look at another problem here. We've got the limit as x approaches 0 of the tangent of 7x over the sine of 3x. So we're taking the limit at a real number value. So the first thing that we're hoping for is continuity. If we can plug that real number value into the function, get a real number back, we can be done with the problem. However, we get 0 over 0 because the tangent of 0 is 0, the sine of 0 is 0. So we get 0 over 0, which is an indeterminate form in calculus. So we're going to have to do some manipulation here. Okay, so we've got the tangent of 7x and we've got the sine of 3x. First off, I'm going to change the tangent into the sine and cosine by using a quotient identity. That means that we have then the limit as x approaches 0 of the sine of 7x over the cosine of 7x divided by the sine of 3x. Okay, so at 0, the sine is 0, but the cosine of 0 is 1. Okay, so we're dealing with all real numbers here. We can do some algebra manipulation. So the first thing that I am going to do is make it the limit as x approaches 0. I've got the sine of 7x divided by the cosine of 7x. We were dividing by the sine of 3x in the previous step, but dividing by the sine of 3x is the same as dividing by the sine of 3x over 1. And dividing by the sine of 3x over 1 is the same as multiplying by 1 over the sine of 3x. Okay, so now we've got all these different functions. We've got sine of 7x over cosine 7x, 1 over the sine of 3x. Well, as we were just talking about, the cosine of 0 is 1. So the cosine of 7x as x approaches 0, this turns into 1. In this problem, it looks like that 1 gets absorbed. But what we've done is we've actually evaluated the limit. So now I've got the limit as x approaches 0 of the sine of 7x over the sine of 3x. Okay, well, the goal next is to basically get these arguments, the angles, the 7x, the 3x, to have the same angle either underneath or below them. Because we've got this to work with up here, which is the limit as x approaches 0 of the sine of x over x, that equals 1. If you did the proof using the squeeze or the sandwich theorem, you would realize that the reciprocal is also the case. So the limit as x approaches 0 of x over the sine of x, that also equals 1. So you can add that to your repertoire as well. So we've got the limit as x approaches 0 of x over the sine x equals 1. Okay, and that's what we're going to do for the sine of 7x, sine of 3x. We're going to get them matched up. In order to do that, I am going to split them up. So I'm going to say I've got the sine of 7x over something times something over the sine of 3x. Okay, so basically, in order to make the sine of 7x as x approaches 0 into 1, I need a 7x down here. Okay? Similarly, with the sine of 3x, I need a 3x up here. Okay, but I can't just arbitrarily go adding a 7x and a 3x to the problem. However, I can add 1. And if I add a 7x to my denominator, I have to put a 7x in the numerator. If I have a 3x in the numerator, I have to put a 3x in the denominator. Now, I have not done anything to the function other than multiply by 1 by 7x over 7x and the 3x over 3x. Now, what this means is that as x approaches 0, sine of 7x over 7x, that becomes 1. 3x over sine of 3x, that becomes 1. So these turn into 1s here and here. So we're left with then our limit as x approaches 0 of 7x over 3x. which means we can cancel the x's. So we've got the limit as x approaches 0 of 7 over 3, and the limit of a constant is a constant. So our answer here is 7/3. Okay.